Hello everyone, welcome to the second of my lecture series. I'm Locke, and this time we have production quality. Yay! Yay, basic stuff. For everyone who was watching yesterday, it turns out that after I recorded everything and everything got done, oh yeah, by the way, random interrupt. I got the overlay, so you can see me and what I'm looking at the same time. Let me know if that works out, if it's better to switch between them, whichever. Just trying new things to see what works the best. But anyway, on yesterday's recording, after I finished up everything, it turns out that it just didn't record audio. So that was great. The video for yesterday is pretty much useless, but that's okay. It's no big deal. It was nothing major. It was just setting up IDE, the Eclipse SDK here. So it's not a whole lot. Hello world, that kind of thing. There are lots of guides online to it. It's not hard. So go Google Eclipse, download this piece of software, and we'll get started. That was pretty much everything you had to know from yesterday. A lot of it was me talking about me, who I am, what I do, all that fun stuff. But we'll get to that just as the days go on. You'll kind of find out about that since I have no audio for you. Can't think about it. So today we're going to start with let's see. I would say one of, if not the most important things you'll have to know about programming, which can be your primitive data types. Okay, so I'm sure most of you know that a computer stores all this information, down at the processor level on your hard, or processor level on your hard in RAM, etc. Is flips on and off of a transistor. It's a 1 or a 0. It's called binary data. We store everything that way, and then we have a set of abstractions built on top of that. Bytes, kilobytes, megabytes, those are sizes. That, depending on who you talk to, or depending on which definition you're using, are going to be slightly different. But we have our layers on top of that. But it all comes back down to just zeros and ones, how we look at that. So our primitive data types are not objects, and that'll make more sense as we get into what objects are. But just for now, remember that they're not objects. So let's see, what are our primitive data types here in Java, which is where I'm going to start. I'll let you know where this stuff doesn't cross over in C, since those are going to be our two main languages. But start with, we have let's see. Start with an integer. An integer is going to be any whole number, a positive or negative whole number, within certain bounds. An integer is going to, it's 32 zeros or ones, which I don't actually remember that max value, but they have a hard maximum, but it's basically just a number. For most of your normal counting stuff, like if you want to loop through the number, or like the lines in a file, that kind of thing, you'll use an integer. That'll be plenty big. A lot of the data types have to do with the size of numbers. I'll just go ahead and test them out. There's a byte. I can type right. And we'll go by all the numbers. But there's a byte. There's a short. All of these are going to be just still integer numbers, just of different sizes. And there's a long. All of those are going to be the same thing. I don't want to say exactly the same or not. They're different sizes of the same thing. A byte is 8 bits worth of number, which goes up 128. 0 to 127. All computer numbers start at 0 and count to 127. If you didn't know that, all the counting we're going to be doing is going to be starting at 0. And then a short is going to be like 16, int 32, and long 64 bits, I believe. Actually, I know that one, but I'm not sure what their max value is. Other primitive types that we'll have that are important are booleans. A boolean is a value that is true or false, but not both at any given time. Also, they get shortened to bools at times. So a boolean is going to be when you're testing. We'll get into those a lot more tomorrow. All of tomorrow's segment is going to be on Boolean logic and conditionals, which is going to be if statements. If this, do something else, which really lets you start adding logic and structure to your programs, which is when you really start to be going, oh, hey, I can do some interesting stuff with this. But for now, a Boolean is just a true or false value. And then we have, let me check my little list. Yeah. You have a character, shortened to char, which is just going to be a letter or any kind of I want any kind of string. We're about to get what strings are. It's a symbol. So I can put in there like a $sign. I can put in any ASCII value, American Standard, something. I don't remember the whole name of ASCII, but it's any like standard writing. And then you have a string, and I know that was a little wonky. Don't worry about it. Well, that'll make sense here in a second. Strings are, you're going to be working with strings a lot. Make sure to capitalize them. Case is very important in almost every language. Notice there that I mistyped that. A string isn't a primitive type in the strictest sense. In the strictest sense of the words, primitive types are only going to be those numbers and characters. But strings, when it comes to Java, when it comes to a lot of higher level languages, strings are going to effectively be primitive types. They're kind of a weird crossover because you don't instantiate them, and we'll get back to what instantiation is later. But they're technically objects, so that'll get a little weird. For now, just think about them as a primitive type. And you can see it's, that's pretty simple, right? I'm sure you can figure out, this equals 100. That's nothing confusing there. Make sure to wrap strings in double quotes and characters in single quotes. That's how you mark them, because otherwise if you leave it out, it's going to think you're working with the variable hello and the variable world there. And you don't have those, and it's not going to make sense. That just won't work. So those are going to be all of your primitive data types. So the next thing you'll have to know is, oh, wow. I just did something completely. I forgot to give you floating point values. Float and your other two very important values are going to be a float and double. Those are non-integer numbers, like equals 3.7 or that kind of thing. There's something with a decimal place after it. And yeah, those are decimal numbers. I can't believe I forgot that. So next thing you're going to want to know is how do you convert between them? Because in a lot of instances, if you start doing math with things, that's going to get really weird. Let me get rid of all this. For example, let's say you have, just for math talking, int a equals 5, int b equals 3, and int, we'll just start there. Okay, so if I want to add them into int c, it's real simple, a plus b. basic algebra. Subtract them. Oh, once you declare a variable, hey, declaration. Once you declare it with its name, you don't have to do that every time. In fact, don't, or you'll be redeclaring it, which will delete the value it already has. You just refer to it by its name. So C equals A minus B kind of thing. But that'll get a little weird. You'll notice we're working with integers. If I divide them, I do int C equals A divided by B, what do you think I'm going to get? And see, it's yelling at me since I've already declared C. It's saying it's a duplicate variable, duplicate local variable C. So don't do that. What do you think is going to happen here when I do this? I'm going to, just to show it to you, I'm going to print it out, just like we printed out hello world up there. I'm going to print it out. So you stop and whatever you think that might be, but I'll show you. It's my computer's really slow. It's going to be 1. Now that doesn't make sense, right? 5 divided by 3 isn't 1. It's 1.6, 4, 6. I don't know. I don't do mental math. I work with computers. I don't do mental math. That's going to be... Now I want to know that. 1.4. Right? Oh, God. You know what? I just can't take it. I can't do mental math, especially on camera. 1.123. I'm slow. Whatever. So, it's not 1, though, right? It's just not 1. What's happening is it's truncating this value down to an integer. Because remember, an integer isn't going to be... isn't going to have a decimal place at the end. So it's just going to take it and chop off everything that's after the decimal. It's not rounding. Rounding would be even more confusing. It's just cutting off the decimal place. So if I instead went here and declared D, by the way, don't actually name your variables like this. I'm just doing it because we're doing simple math, but you're going to want to make them generally descriptive, like int file line kind of thing. But let's say I do int, double D equals 3, and then I do double E equals A divided by D. Okay, now what do you think will happen here? I would hope. Oh wait, I've got to print things. You'll notice you'll do this a lot when you start writing your code. You'll forget really basic stuff because you'll focus on, what you're focused on, and then the actual. Come on, yeah. See, now it'll be your value. A double is going to be holding that integer or that non-integer rather, that value. So useful to have, but you'll notice it did that because I took an integer and divided it by a double. And what it ended up doing there is casting, which is the next thing we're going to have to get into. Casting is how you convert from one data type to another. So let's roll out. Let's say that let's say you want A to be a double. Well, I could, just say double C equals A, and it'll do the casting implicitly for me. Implicit casting is where you don't write it out, but let's just say we want to, use it somewhere else. I want to print out the double value of A. What you're going to do is you're going to do open bracket, the variable inside, or the variable type rather inside, close bracket, and then the value. And when I print it out, it's not going to show you anything different, but 5.0, see? But it'll convert it into that type. That's called casting. But you can't just cast everything. It's not going to work. Because casting will only happen in a certain order. You can only cast up in the sense of you can only cast from more specific to less specific. And there are certain exceptions. This is a more specific to C in the lower level languages. For example, you couldn't do this. You couldn't cast from an int to a double because that's adding precision. In Java, it'll let you do it because it's a little newer. But in general, just keep in mind when you're casting that you can lose information. If I cast C there into an int, it's just going to return 5. It just drops that in part. And you have to be really careful. You can just cut off your value there. But you can do all your basic math between there. It'd be a perfect recommendation if you're going to be working with things like money, things where you're going to be very, very precise as we go forward. Do all of your addition, subtraction, using integers, and then only move into doubles and that kind of thing if you absolutely have to. But that's a little farther down the road. Anyway, so your other kind of like pillar that you'll be working with a whole lot is going to be string. You can see I have just a explicit string up here when I print out hello world. But I can do string whoops. Hi everybody. And I'm going to do this specifically. You'll notice this. You can't declare a variable after you call it. Things I've done. Don't try to do that. You can only try to use a variable after you've said what the variable is, right? That just makes sense. So here, it's going to do the exact same thing. Prints out, what I said there. But let's say I had down here, there's a lot more stuff. There's, lines way down here. But I still want to be able to change this. Let's say I had, this is maybe a bad example now that I think about it. Let's say I have lots of those for some reason. They're spread out all across the code. And I want to change this variable. Let's say it's an error message. And I want to change what it is. I can just go up here and say, Robinson Danger. I can go change it up there, and then every time you call that, it'll do the exact same thing. I mean, it's pretty simple. I'm pretty sure that's not going to throw you for a huge loop. That's how variables are going to work. It's only gets confusing when you start getting into the little nitpicky details of certain things like casting. I promise you sometime in your programming career you'll cast something and you'll lose some data and you'll be like, wait a minute, what just happened? It's because you have to pay attention to little stuff like that. But things to remember. If we switched into C, and it doesn't seem worth it to switch for just this one example, but you switch into C, things like a string aren't going to be just available to you. You'll need a library, and we'll get into how libraries work and how you can import all that in a little bit. But for right now, that kind of thing, you'll be limited to characters and numbers. So always be aware of what you're working in. I mean, obviously C has strings. You just need to import a library, but you can forget to do that, right? Let's see. So you know what variables are. You know how to cast between them. Oh, something cool. Integers and characters are different representations of the same thing. Or more accurately, characters are a subset of integers. And then if I do that, and then I do this, I cast it to an int, that might confuse you a little bit. Well, how do you, use the right variable names. How's it going to convert from a letter to a number, right? Those things don't translate. I mean, maybe you think it's 0 because it's starting in the alphabet. Actually, it's going to convert to 97. And why 97? That thing I mentioned earlier, ASCII, it's an official agreed upon conversion chart from letters to numbers. And the first I don't know. Let's type. All the numbers before capital A are reserved for special symbolic. What's the error? Oh, variable A, capital A. Reserved for special things. Let's see, God. Learn to read my own variables, right? Yeah, so A starts at 65. I couldn't tell you what they all are. I don't know why they agreed upon that way, but a character is actually going to be an integer, which can be useful for comparing them, or if you want to try to convert things in that way, just so you're aware of that. That kind of thing is really useful. So you know what variables are. You can see how to manipulate them. It's really assignment statements. You know, if I actually think I said this is how you assign a variable. You use the equal sign. Yay. So you know how to assign variables. You know how to manipulate variables. You know how to cast them, which is really useful. Something you're going to have to know, when you switch between languages, not all languages are going to declare their variables explicitly like this. So I'm saying A is an integer, and then I can cast it into other things. Not all languages do that. It's something called strong versus weak typing. Java here is strongly typed. This variable, you know exactly what type it is at compile time. I can say that A is always an integer, and C is always a character here. But that isn't always the case. If you work in a language like PHP, PHP is going to just have a variable. You can do whatever you want with it. And it'll do all of the casting and converting behind the scenes. On one hand, that's kind of nice, because you don't have to worry about it. You can just, do variable here. I'll really make it look weird and type some PHP in here, but you do like variable counter equals 5. I like 5. I don't know. 5. That's how you declare a variable in PHP, right? But you don't know what kind it is, and it does all the conversions behind the scenes, and then you only know what type that variable is at runtime, when the program's actually running. At runtime is going to be when it's running. At compile time is going to be when you come up here and compile. That's because PHP actually isn't compiled at all. Compiling's, in case anyone doesn't know, is when you the computer goes through the code and compresses it down into machine code, the actual processor instructions. PHP doesn't do that. It interprets the code on the fly. So it's not necessarily why it's weakly typed, but it is weakly typed. So something to be very aware of if you're going to branch out into lots of languages is be aware of typing. So let's see. Well, I guess we're talking about Booleans tomorrow, but I'll preview, I guess. Boolean demo, I don't know. Someone once said, I don't remember who, but someone once said the only two things programmers, it's difficult for a programmer, are naming things, and I don't actually remember the other. But the important one is naming things. Coming up with good variable names. Really don't do what I'm doing right here. If I pull up my code sometime and show it to you, use well-defined variable names that say what that value is, right? Don't do everything in letters or demo and stuff like that. It's not good. That's true. Why are you? Okay, yeah. Sometimes it's a little slow. It'll say something's wrong. That's not. But that's all this is. It's a true or false value. That's what Booleans are. We use them in something like this, where if that's true, then we're going to have another little block here. And we'll do, and then else, meaning if not this. We'll get into this tomorrow. I just thought I'd kind of show it to you so you know why we have Booleans. Else and D equals A minus B. So you can see right here, this is where you're going to start getting into, oh hey, cool stuff. right? Because you can start saying, well, if this is true, otherwise do this. You can look at the state of a program and then go from there. So let's see. I think, let's see, casting, data types, declaring data, manipulating data. Oh, I said I would talk about assignments today. I wouldn't go as far as to say, hey, go write this program. Don't do that. Okay, no, actually, go do that, but don't do it because I say so. Go, everything I talk about after you watch this, go out and play with it a bit. Go assign your own variables once I'm done. Go, add them together, do some math with that, do some strings, print them out, maybe kind of follow what I did along. Go do that so you can kind of see how it works and then just play with it. That's the biggest thing, is I can sit here and talk for the next 8 hours about how to program, and you will feel very informed when I'm done, and you'll sit down in front of a computer and go, what? And it won't work. You have to go play with it. That's true of almost anything. Is you can watch someone ride a bike all you want, but if you go do it and fall down a few times, you're not going to pick it up. So I would always recommend going through that. And then I can present some ideas if you guys want, of some cool stuff to do, stuff I've done, stuff I think that would be cool to do. But that'll be a little bit later. So this ended up being kind of short again. Maybe I talk too fast. I should slow it down a bit. I'm not sure. But that should be everything you need to know on basic data types. If you have any questions, there are a million ways to get a hold of me. Either post on this video after you watch it, or you're in chat and then I'll see it in a second, or email me if you really want to. Though I would say I would prefer things on the comments. But yeah, that's everything. Oh, we have fun transitions. Let's see if they actually work. Yay! You can, where there's a shell, there's a way. Yeah! Cool little background. But I have transitions. I'm happy about it. I'm learning the whole streaming thing. I'm learning along with you. So, yeah, I will hear from you guys tomorrow. Have a good day.